Hi everyone. Today I'm going to be talking about how to write an effective research hypothesis in psychology. In a previous video, I've described the difference between a statistical hypothesis and a research hypothesis. If you're interested in learning about that, I've linked it for you below. So let's start off by describing what a research hypothesis is. Well, a research hypothesis is a testable statement which predicts how two or more variables will behave in a research study. It's a statement that's a scientific claim, and it might do one of two things. It might predict a causal relationship between two variables, so for example, what the group difference is, or it might make a relational claim. So it's going to predict how two variables might co-occur. As we know, this is different to a statistical hypothesis, as represented by the null and alternative hypothesis. The goal of the research hypothesis is to set the stage for going out, designing your study methodology, collecting your data, which will allow you to test its truth. In terms of where you'd find a research hypothesis, you could find this in a lab report or a journal article. To write an effective research hypothesis, you need to consider a few foundational elements. So firstly, it should predict an effect. If you're not predicting an effect, what you've actually got is a null hypothesis, and that's not what we're trying to write. It should ideally be directional. There are very few instances in which a non-directional hypothesis might apply. This is generally when the literature is very unclear and has found contradictory findings. And so you have no way of predicting which way the results might go in the current study. Also, highly experimental or new areas of research may warrant a non-directional hypothesis because there's just simply no way of guessing which way the results might go. But other than that, for the most part, you should be providing a directional hypothesis. Your hypothesis can't be vague, otherwise it's not testable. So it must be possible to operationalize your theoretical ideas. And naturally, you want your hypotheses to flow logically from the background information provided in your introduction section, including the aim and the rationale. So what do you need to know before you go out and write your hypotheses? Well, firstly, you need to know what your independent variable is, or your grouping variable, and how many levels there are. And you need to know what your dependent variable is, or your outcome variable. This is the variable that we're interested in making a comment on. And you need to know how it is that this has been measured. So what tools or questionnaires have been used in order to determine this outcome. So what should you include in a hypothesis? Well, firstly, you might want to use the word hypothesis. This really clearly demarcates to your reader that they've reached their hypothesis or the predictions for the current study. So you might say it is hypothesized that. You could also say it is predicted that. However, the word hypothesis certainly clearly demarcates what it is that you're here to do. You want to know the clear names for the levels of the independent variable, which we know is our grouping variable, and you want a clear name for your dependent variable or your outcome variable. More than that, we need to know the unit of measurement and how we're going to operationalize our dependent variable. I'll go ahead and describe what operationalizing means and how we might go about doing that in a minute. We also need to know the direction. So we need to know which group is going to score higher than the other, for example, or if we're predicting a positive or negative relationship. And we know that we should be predicting an effect rather than no effect, which is represented by the null hypothesis. So what does it mean to operationalize a hypothesis? Well, this is a process where you strictly define the variables into measurable factors. And so you might start off with a very vague concept or idea, but you need to be able to measure these empirically and quantitatively and convey this to the reader. So by defining the exact measuring method used, it allows other scientists or researchers to follow the exact same methodology that you've used in the current study. So how would we go about operationalizing the independent variable? Well, we know that this is related to our groups. So we have our broad variable. It might be gender, for example, but we need to be more specific than just saying gender. We need to provide the levels. So in this case, it would be males and females. Another example could be injury severity. This is our broad independent variable or our grouping variable. However, we need to move beyond that to operationalize it by describing the levels. In this case, it could be mild, moderate, or severe injury severity. How would we operationalize our dependent variable? So the three things that we need to know are the broad variable name. We also need to know the scale of measurement. So what tool are we using in order to measure our outcome? And we may also need to know the specific unit of measurement. So an example could be our broad variable is fatigue. The tool that we're using is the fatigue severity scale. And the way participants respond on this scale is by providing a rating. Another example could be our broad variable is income. Now, that's not specific enough for another researcher to read that and understand how to replicate that study. So we need to be more specific in describing how it is that we're coming to our outcome. So in particular, we're interested in capturing gross annual income. So we're not interested in fortnightly wage or monthly wage. We're interested in the gross annual income. And our unit of measurement is in dollars. We could even go a little bit further than that and say Australian dollars or US dollars, for example. The way you write your hypothesis is going to depend on your study design and what statistical analysis you plan on undertaking. And the goal is that the reader should be able to guess what type of design or analysis you might have on the basis of your hypothesis. So therefore, language is extremely important. So each word should be serving a purpose in your hypothesis. Let's look at a few examples of some important words. The word difference. If you say the word difference in your hypothesis, you're suggesting to the reader that you've got an experimental or quasi-experimental design where you're looking at group differences. So this might map to an analysis such as the t-test or an ANOVA, which we know looks at group differences. You also, if you say the word relationship, you are suggesting that there's a correlational design in the current study. So an example of this could be the Pearson correlation. Equally, if you say the word predict, you're suggesting a regression type analysis or some type of modeling. So if you're not using a predictive model, such as linear or multiple regression analysis, where you're trying to guess the outcome of one variable on the basis of another, but rather you might simply be just looking at relationships, so how two variables co-occur, then you should not use the word predict in your hypothesis. Equally, if you're looking at relationships, so in a correlational design, for example, using a Pearson correlation, you should not use the word difference, which is indicative of a t-test or an ANOVA type analysis. Let's have a look at some examples of effective hypotheses for group differences. So let's just say we're looking at using a t-test for this first hypothesis. In this case, we've hypothesized that females will score higher in percentage than males on an end of first year mechanical engineering exam. Let's break this down in terms of the important components of the hypothesis. So importantly, we have the levels of our independent variable. In this case, we've got females and males. We've got our dependent variable. This is the very broad variable of interest. we're looking at a score. Now, a score doesn't tell us much. We need a little bit more information to know how it is that we've reached our outcome. So we've got our unit of measurement. We know our score is represented by a percentage. And we've also operationalized our dependent variable. So how is it that we're getting this score? Well, we're looking at students' first year mechanical engineering exam results. And lastly, we've got a direction. So we've indicated that females will score higher than males on this mechanical engineering exam. If you had a non-directional hypothesis, you would just simply be describing a significant difference between the females and males in terms of their mechanical engineering exam results. However, you wouldn't be describing higher or lower. Here are some examples of effective research hypotheses when looking at relationships. For example, using a Pearson correlation. This first one describes that in the general population, it's hypothesized there will be a positive relationship between income, as measured by gross annual income, and years of education. So let's break this down a little further. So importantly, we've got our two variables of interest. We've got income and education. Now, this isn't enough information for us to understand the tools or outcomes that we're using to measure these. So we need to specify the units of measurement and operationalize these a little further. So for education, we've got our unit of measurement, which is in years. So we're not measuring, for example, months of education. That would be quite strange, but it's possible. So we've got years of education. Equally, we could look at something like level of education, in which case you would be looking at something like tertiary education, completion of high school, etc. However, that's a dichotomous type nominal variable. And so for a Pearson correlation, we need to be looking at using ratio level data. So years of education is going to produce a number for each participant in the study. And we've operationalized income. In this case, we're measuring it in gross annual income. You could go a little bit further here as well to describe in Australian dollars or US dollars, for example. And lastly, we have described a positive relationship. So we provided an indication of the direction we anticipate the results will go. So as annual income increases, as years of education increase, so too does income. It's really up to you to examine the results from the statistical analyses undertaken and interpret whether or not your research hypothesis is supported. And your interpretation of this would be provided in a discussion section of a report. A common mistake is to provide an interpretation of this in the results section. However, this should just be reserved for describing the statistical analyses undertaken. In your discussion section, this is where you'd consider whether or not the hypotheses have been supported, and you would place this in the context of the prior literature. I thought I'd briefly mention how to go about writing an aim, because these two are often confused, and students often write aims the same way they would write a hypothesis. So the aim is much more general than the hypothesis, and it should not be operationalized. You want to only include the broad variable of interest and not the units of measurement or the tools associated with determining the outcome. So an example of this might be, the aim of the current study is to examine the efficacy of fluoxetine in treating depressive symptoms. So note that we haven't prescribed the dosage or the unit of measurement for the medication. So we haven't said 5 milligrams or 10 milligrams, for example. Equally, we haven't described the questionnaire used to measure depressive symptoms. I hope you found this video helpful in describing how to write an effective hypothesis for psychology. Thanks so much for listening.